Hi there! This series covers the first 100 Project Euler problems to help you learn how to solve unfamiliar problems. Project Euler presents complex math challenges to be solved with programs running in under a minute. Although they prohibit sharing solutions, the first 100 problems can be shared for instructional purposes. I encourage you to attempt each problem on your own before watching the corresponding video. I am currently learning Python and have been doing so since mid-January. I have no professional experience in the language and have only completed the Python for Programmers course on Execute Program. While I'm learning quickly, I don't claim any real expertise. Today, we're looking at the 62nd Project Euler problem. As always, I will link to the problem and my repo in the description. Let's dive in. Problem 62 is cubic permutations. The cube number can be permutated to produce two other cubes, blah and blah. In fact, that number is the smallest cube, which has exactly 3 permutations of its digits, which are also cubed. Find the smallest cube for which exactly 5 permutations of its digits are cubed. Okay, so straightforward enough problem statement. Let's go ahead and get started. Okay, so here's my basic thought as to strategy. First, we'll go through numbers, find cube, make permutations of cube, discard any lower value, count how many of the permutations are also cubes. Well, yeah. Lower or equal value, to be honest. Okay, so from an algorithmic standpoint, this is pretty simple, right? Just keep going through numbers, looking for a cube. The permutations we did run into an issue with before. Remember, if you've been watching for a few videos, you might remember very recently I ran into a problem where using the permutations from editor tools did not work, but that is because it was a very large set that we were combining. So we can safely use it here, I think. And then in order to know whether these permutations are in fact cubes, we're going to have to find the cube root. According to Stack Overflow, there is math. There is a square root function. Cool. Okay. So, start off with x equal 1. Or even... yeah, we'll just leave that. Yeah, this will be fine. While true, again. pretty dangerous to have a while true loop. X plus equal to 1. I guess I'll start this at 0. It doesn't actually matter. It's definitely not going to be the first few digits, right? Then cube is equal to okay, so exactly 5, and that is 5 including itself. Okay, so cube equals x to the third. And then terms is equal to list of permutations of the list representing all of the digits in cube as strings, except discarding any with a lower value can also be done here. Not if I use the wrong symbols, but you know. P for P in that if P greater than Q. Okay, so that'll discard all of these other ones. Okay. Count is equal to 1 for perm and terms. If is cube perm count plus equal to 1. If count equals 5, print found I'm gonna say found smallest cube with exactly 5 permutations being cube. And just print out cube. And then we break. And that's it. Of course. This is the tricky part. So I'm going to go ahead and break that out into a little function of its own, because I've decided I like doing that, apparently. So it is cube, and I'm just going to call this n. So root equals okay, and now we have to figure out if this is an integer. And we already have that code in a previous place, which is here. So actually, I don't think we even need the greater than 0 part. I think we just need the root. Going back here, we'll also cover the negative case. So as helpful as I wanted it to be. I could single line this. I'm going to single line this. Now, of course, I could, since this is now a single line function, bring it back down in here, but I like calling out that that's what it does. So now, with luck, this will just work. But instead of having this while true, I'm going to make this while x is less than literally 1 million. Just so that it has a break condition. Even if we don't find the number. Okay. Right. So this is going to be a tuple for some reason. So we have to join all of these string digits together, convert them to an integer, and etc. And I'm also just going to real quick do this part. So this is just making it so that if there's a 0, leading zeros... Well, no, leading zeros would be gotten rid of anyways, because this is a greater than. So, this is fine. Okay, so that found the answer effectively instantly. Or found an answer, I should say. And I can't help but notice that this number is a lot smaller than this number, so this answer, probably not correct. Yeah, I didn't think so. Okay. Okay. This will be a very long number, but... Okay. I feel like this is somehow giving us the exact same number far too many times. So we'll convert this into a dictionary real quick. That'll be the perm array, which I know is a list. And then for R in, nope, can't say X. For R in, I'll just say A for A and perm R. Perms dot perms A equals 0. Now let's see if we find something else. Okay, so it's running a lot longer now. I'm going to go ahead and exit out, or cross out of that, so that we can delete that one, because that significantly slows down the runtime. Okay. And it shouldn't take too long to go through the first million numbers regardless, but let's kind of see how it goes. Obviously, having this permutations thing is going to slow us down a bit. But we're just going to go ahead and let this chill. I think that it is probably taking longer than our minute time limit to run. But we shall see. Yeah. Definitely going to take more than our single minute to run, but I wonder if it'll be done in just a couple of minutes. And in any case, this might be too many. We're clearly not getting there yet. When X hits a million cubed might be too many numbers, because that'd be like so many zeros. Goodness. Obviously, this is taking quite a while. Let's see. Python default R. Okay. So we're doing it correctly for using these permutations, but we're not getting to the correct answer in a timely manner. And since we're still not getting to the correct answer, it's going to be the cube of a very large x, I think. I am confident that this will give us the correct answer, but it's taking quite some time, especially since it's getting into these much larger numbers. I'm sure those are a bit longer going through the permutations. Yeah, I'm calling it there. Let's go ahead and drop this down by a couple of zeros just to see. I think now it'll probably go through in a reasonable amount of time, but I'm not certain. Actually, before we do go through all of that, going back to our problem statement, so these are all cubes of 3-digit numbers. I am going to guess that if we go up through all of the 4-digit numbers, we should be finding it. And just to be completely certain, we'll throw in another print here. This is going to be behind an if x mod 1000. That. So my guess is it's going through the first 1,000 numbers pretty quickly. Oh, whoops. It's important to do the equals 0 part. Okay, not quite true, but... Okay, so even the first 1,000 numbers are taking quite a while. I'm gonna give it a minute just to see. I think it's just that this permutations function is exceedingly not performant. So instead of making a list of all permutations of every cube, let's try a different approach. Let's make that a dictionary. And now, instead of being like, it's cube, we're going to say, let's see, so here's what I'm thinking. We're going to go through and instead of making permutations of cube, we're just going to go through and find cubes. And for each cube, we are going to see if... Okay, there we go. So this is obviously very, very badly performant. So every time we find a cube here, we are going to convert it to a sorted... Ooh, how we do this? Convert it to a sorted array. And say how many permutations are for that sorted array. So this will find the 5th cube instead of... Ooh, but how do we know it's exactly 5 and not 6? Well, I think that's a reasonable assumption, is it won't be 6. It'll be exactly 5. Maybe not. In any case, instead of making permutations of the cube, we are going to have this. Cubes. If the nth version of the smallest permutation equals... Well, no, there's no sense in checking that. Okay, so we got the smallest permutation of the digits that is possible. And what we're going to do is get data equal to cubes for smallest perm. And then if data is null, none. It's none in Python, not null. If data is none, equal to the tuple of cube and 1. Else data at index 1 needs to plus equal 1. I think that'll work. Let's type this one out. Okay. So if data is none, we have found the smallest cube. Otherwise, we have found a cube that is a permutation of that smallest cube, and we need to increase the count for that smallest permutation. And this is going to be a little bit wonky of a way to do this, but I think it might work and work faster than that permutations method. But okay, so now when we go through all of our stuff here, we no longer need our is cube. Or do we need that? What we do need, though, is find the smallest cube. And I'm going to have this equal to what's a good arbitrarily larger number? Let's see. Yeah, that's probably a big enough. I'm gonna add a couple more just in case. 6, 9. Yeah. 4. Data in cubes dot values. If data 1 equals 5 and data 0 is less than the smallest cube. The smallest cube equals data 0. Okay, so this is kind of a rough way of doing this, but it should work. The question really is whether it's performant. Okay. Key error 1. I guess I need to instead do if smallest perm not in cubes. Empty tuple. these two lines. So now we're saying if this permutation is in cubes, then we are going to get the data from it and increase the count by 1. If it isn't, then we are going to set the data to cube, comma 1. Tuple object does not support item assignment. Right. Okay. So data equals... I believe it does support this sort of okay, so that found an answer instantly, and let's see if it is the correct answer. It is. Alright, so not super bad for a 15% difficulty rating. Just took finding the correct algorithm, as always. I don't know that this is very straightforward way of doing this, and this is just assuming that the x is going to be 4 digits or less. I don't even know what the x for this is. And I am... So, like, this one I'm just doing a very, very quick go through these 10,000 numbers check. And this can now be a for loop. And it should work exactly the same. It does. And all we're doing is we're kind of converting it to a sorted string. Then actually we can cut out a line here too, can't we? We just start it as cube 1 and then reset it only if it's there. Cool. Saves us a couple lines. Not a big deal. Not gonna save us any efficiency, I don't think. And then we just assume that the smallest cube has to be smaller than whatever this number is. And we just go through, find all of the permutations that are represented 5 times. And check whether it's the smallest cube. Save it. And print that out. So very quick, and the reason it's so quick is because this is actually an O of n. We've given up our nested looping. So yeah, that's it for today, and I'll catch you in the next one.